Good morning, dear students. Today we are going to discuss topic orbital speed of satellite. This is from class 11th physics. To understand what is orbital speed, we have to understand what a satellite is. So a satellite is a body which is revolving continuously in an orbit around a comparatively much larger body. And what is orbital speed? This is the minimum speed required to put satellite into its orbit around the Earth, or we can say around any planet. And that minimum speed which is required to put the satellite into its orbit around the Earth or any planet is called orbital speed of satellite. Now let's derive the formula for orbital speed of satellite. For this is the diagram. There is Earth, and around the Earth the satellite is revolving in an orbit at a height h and at a small distance r from the surface, from the center of the Earth, not from the surface of the Earth. Now let us assume that capital M is the mass of Earth, capital R is the radius of Earth, small m is mass of satellite, small v is orbital speed of satellite, small h is height of satellite above Earth's surface, small r is the radius of orbit of the satellite. Now this small r is the distance of satellite from the center of the Earth. So this is equal to the radius of the Earth plus the height at which the satellite is orbiting along the Earth. This v is the orbital speed with which the satellite is revolving around the Earth at height h. Now the centripetal force required to keep satellite in its orbit, we know that centripetal force is required to follow a circular path. Now here that centripetal force required to keep the satellite in its orbit is given by F, and this is equal to mv square by r. This formula we have already derived in our previous lecture. Here this r is the distance of the satellite from the center of the Earth. V is the orbital speed and small m is the mass of the satellite. Now, according to Newton's law of gravitation, gravitational pull or gravitational force acting on the satellite is equal to G into capital M into small m divided by r square. Here G is universal gravitational constant, capital M is the mass of the Earth or any planet, and small m is the satellite's mass, and r is the radius of the orbit of the satellite, that is the distance of satellite from the center of the Earth. And this is given by r plus h, where capital R is the radius of Earth. Now we have understood this, that the gravitational force is playing the role of centripetal force here. So gravitational pull provides centripetal force. So mv square upon r is equal to capital G into capital M into small m divided by r square. From here we can get the formula for orbital speed, which comes out to be v is equal to under root gm upon r, where small r again is the radius of orbit. Now we know that acceleration due to gravity of Earth, that is small g, is equal to g into m upon r square, where g is gravitational constant, m is the mass of the Earth, and r is the radius of the Earth. From here we can get the value of gm, and gm comes out to be gr square. We can put the value of gm in our first equation, then we get another formula for v, and that is gr square upon r under the root, or this r square can be taken outside, so the formula finally becomes capital R into under root g upon r plus h. From these two formulae we can come to conclusion that orbital speed of satellite, first of all, is independent of the mass of the satellite. Second, decreases with increase in radius of orbit or increase in height of satellite. From these two formulae we can see that v is inversely proportional to the radius of the orbit, and v is inversely proportional to the height at which the satellite is revolving around the Earth or any other planet. Third, it depends on mass of Earth or the planet. So from the equation 1, we can see that orbital velocity or orbital speed depends on the mass of the planet, which is capital M. Now beta, let us discuss a very interesting topic, that is motion of satellite. So motion of satellite. Let us consider Earth. Now, if we want to put this satellite into orbit of Earth, that to circular orbit of Earth, then we have to provide it minimum speed, which is orbital speed, and that speed comes out to be nearly 8 kilometer per second. How did we get this speed? By putting the value of v of different terms which we have used in the formula, that is v is equal to gm upon r square, or r, or g is equal to r into small g upon r plus h. We know the value of small g, this is 9.8 meter per second square. We know the value of r, which is 6400 kilometer, and we will also know the value of height at which we want the satellite to revolve above the surface of the Earth. So putting all these values, we get that if the satellite has to revolve around the Earth in circular orbit, then the orbital velocity speed should be 8 kilometer per second. And does this mean that the satellite can always revolve around the Earth in the circular orbit? No. This means that if the speed of the satellite is less than 8 kilometer per second, then the satellite will not follow circular path, it will follow the elliptical orbit. So, if the orbital velocity is 8 km per second, then the satellite will follow circular path, and if the velocity is less than, orbital velocity is less than 8 km per second, then the satellite will follow elliptical path. So, there are two velocities, orbital velocities, in which the satellite can revolve around the Earth. The first one is when v is equal to 7.9 kilometer per second, or nearly equal to 8 kilometer per second. In this case, the path will be circular, and if v is less than 8 kilometer per second, then the path with which the satellite will revolve around the Earth is elliptical. So elliptical, you know, this is the shape of ellipse, and circular, you know, this is the shape of circular orbit. So it has to be a closed orbit. There are other two paths also which a satellite can follow, and that is parabola and hyperbola. The satellite follows a parabolic path when the speed of the satellite is more than 8 km per second and is less than 11.2 km per second. In that case, this satellite will follow parabolic path, and it will leave the gravitational field of the planet or Earth, and that speed is 11.2 km per second, and with this speed the satellite escapes from the gravitational field of the planet, and this speed is called escape velocity. And if the speed of the satellite is even more than 11.2 km per second, then the satellite follows hyperbolic path. If v is greater than 11.2 km per second, then satellite follows hyperbolic path. And if the speed is 11.2 km per second or more than 8 km per second, then the satellite will follow parabolic path. And with these two paths, the satellite will escape from the gravitational field of the planet or Earth. And this 11.2 km per second, this particular velocity is called escape velocity, which we will discuss in our next lecture. So in today's lecture, we have discussed about the orbital speed of the satellite, and orbital speed is the minimum speed with which the satellite should be put in an orbit around the Earth or any other planet, and its formula is given by v is equal to gm upon r under the root, or v is equal to r into under root g upon r plus h, and its value comes out to be 8 km per second if the orbit is circular, and if the orbit is elliptical, then its value is less than 8 km per second. I hope you have understood today's topic, beta, and you all are perfectly fine at home. Just study well and follow all the norms of COVID. Thank you. Take care.